Hi, fifth grade students. Welcome to lesson 1-1, Patterns with Exponents and Powers of 10. Our learning goals for this lesson are going to be written as I can statements. I can calculate a product by multiplying by a power of 10, and I can use exponents to write powers of 10. Please write these I can statements and the lesson title in your math journal. If you need a moment, you can press pause and then restart the video after you've written this information down. The next slide is titled Vocabulary. Please write the term vocabulary in your math journal. We have 3 vocabulary terms that are related to this unit. The first term is the term base. And instead of having you write down a sentence about what base means, we're going to have you actually write down what is below the word base. So when we're looking at this word, the word base means the number we will be multiplying. So in this instance, it's showing us the number 10. The next vocabulary term is the term exponent. And you'll see that there's an arrow pointing up to the small 3 next to the 10. An exponent is a number that tells you how many times the base number will be multiplied. Now, both of these will make sense when we come down and look at the word power. Power is the product that results from multiplying the same number over and over again. So when we look at this problem where it says 10 times 10 times 10, that can be written as 10 to the third power. 10 to the third power just means 10 times 10 times 10, and that's equal to 1,000. A common misconception when students work with exponents is that they sometimes think that when they see 10 to the third power, that means 30. That is not correct. It means we're going to multiply 10 3 times. So it will look like 10 times 10 times 10. If you need a moment to write these down, please pause the video and restart whenever you're ready. We are now at the part of our math homework where we are going to work on solving a problem. This problem is referred to as our solve and share problem. The purpose of the solve and share problem is to build your math understanding by connecting your prior math knowledge to a new math idea. So we'll be starting this by giving you a problem, and this problem is already in your math journal. We've already set up a page in your math journal with this problem that's divided into a 2-column note with an area to summarize at the end. Before we start to tackle this problem, I want to go through kind of our structure that we're going to use whenever we're solving a problem like this, especially a story problem, or they're sometimes called novel problems. We're going to use the acronym CUBES to help us follow a structure to tackle a problem like this. In our classrooms, we have a bulletin board that has cubes on it, and each letter cube stands for a specific step whenever we're solving a problem like this. The C in cubes stands for circle the numbers in the problem. So after we go through and read our story problem, we're going to go through and circle all of the important numbers that are in this problem. Our problem is that a store sells AA batteries in packages of 10 batteries. They also sell boxes of 10 packages, cases of 10 boxes, and cartons of 10 cases. How many AA batteries are in one case, one carton, and 10 cartons? Solve these problems any way you choose. So I'm going to go through it. I'm going to circle the numbers in our problem. We have 10 batteries, we have 10 packages, We have cases of 10 boxes, and we have cartons of 10 cases. We also have to find how many AA batteries are in one case, in one carton, and in 10 cartons. The next step that we're going to follow as part of cubes is we're going to underline the questions that we need to answer. So our first question, let me change colors here, is how many AA batteries are in one case, are in one carton, and are in 10 cartons? So we have 3 questions that we need to find the answer to. The next thing that we are going to do is we're going to box any keywords that we see. Change colors. So we know that we have to do packages of batteries. We also have to find boxes of packages, cases, and cartons. The next step is to evaluate and visualize what's going on in this problem. A way and a strategy that I have used that helps me, especially in a story or novel problem like this, is to kind of put myself in the problem and think of it as a real world situation. So for this problem, I'm going to think about if maybe I worked in this store and maybe my boss said, how many AA batteries are in a case, in a carton, and in 10 cartons? How would I figure that out if I really needed to know that in a real life situation? And then finally, I have to solve and explain the answers. So at this point, this is when we're going to ask you to just pause the video and take a little time to answer the questions of how many AA batteries are in one case, one carton, and 10 cartons. So you're going to be answering 3 different questions. In your math journal, we want you to show all of your work. And then when you finish solving the problem, you can hit play. And I'm going to show you a solution and a strategy that I use to solve it. And then I'm going to show you a couple other ways as well. So please go ahead and press pause at this time. Now that you've had some time to work the problem, I'm going to go through and I'm going to work the problem as well, just to kind of show you what my thinking and my strategy would be. So the first thing I know that I need to look at is I need to know how many batteries are actually going to be in a pack. So if I go over here, I know that in one pack, there are 10 batteries. Now I need to figure out in a box, they also sell boxes of 10 packages. So I know that a box is going to have 10 packs. So that's going to be 10 times 10. I know that 10 times 10 is 100. Now the next thing I need to know is that they have cases of 10 boxes. So each box is going to have 100. So I'm going to do 100 times 10. 100 times 10 is 1,000. So I know there are 1,000 batteries in that case. Now, I want to kind of bring in the idea of exponents. That was a vocabulary word at this point. 1,000 is the same as 10 times 10 times 10. And we knew from that vocabulary picture that we looked at, 10 times 10 times 10 can be written as 10 to the third power. Kind of a trick or a strategy that I learned a long time ago is that I know that 10 to the third power, when I write that, is going to have 3 zeros. So if I don't want to work out 100 times 10 or 10 times 10 times 10, I can write a 1 with 3 zeros after it, and I know I've written that correctly as 10 to the third power is equal to 0. So at this point, I've figured out how much is in a pack, in a box, and in a case, but I really just answered the first question, right? I needed to know how many batteries were in a case. Now I need to figure out how many batteries are in one carton and how many are in 10 cartons. So if I go back to the problem and I read that there are cases of 10 boxes and cartons of 10 cases, then for the next thing I need to write down cartons, and cartons are going to be 1,000, so I already figured out the amount in a case, times 10. That's going to equal 10,000. And now I need to figure out how many batteries are going to be in 10 cartons. So I would multiply 10,000 times 10. And that is going to equal 100,000 batteries. That was the way I worked out my solution. Let's look at a couple other examples. This is a student sample solution, and Victor worked his out similar to the way that I did. He didn't write anything about exponents, but he had that one pack was 10 batteries, a box was 100, a case was 1,000, a carton was 10,000, and 10 cartons were on 100,000. So you might have done something similar to that. You can kind of notice a pattern to Victor's work as we look at this, that each time there was another zero that was in each of those answers. Gabrielle's answer she didn't write it out as a traditional math problem for multiplication or as exponents. She actually drew something visually to represent how many batteries were in each box. And you might have done something similar to this. So she knew that each pack of batteries, there were 10, and that there were 10 packs in each box. So she drew out how many batteries were in the box. And then for each box, she knew it took 10 boxes to make a case. So she knew within a box, that's 10 times 10 is 100. So then she drew 10 boxes that each had 100, that equaled 1,000 for a case. And then she did the same thing for a carton. She took that one case, each had 1,000. There were 10 of them. As she multiplied those, then she knew that a carton had 10,000, and she multiplied 10,000 times 10. So each one of these has 10,000 times 10, and that gave her 100,000 batteries. So lots of different ways you can work this out and still get the same answer. There's many different strategies that you could have used. And you might have used a strategy similar to those, or you might have a totally different way of thinking about it. At this time, you're going to summarize your thinking below your work in the summary portion of your two-column notes. In that, we want you to write about your process of how you came up with this. You could say, you can also add in there my answer that I got, or my strategy was similar to the teacher's or to Victor's or to Gabrielle's, and talk about how it was similar and different. So you'll write a few sentences to describe that, and then you'll be ready to share your problem-solving method in class tomorrow. Thanks for your hard work, and we'll be talking about our solve and share problem tomorrow in class.